Then we have polycythemia vera, and in this case, the mutation we should really mention is the Janus kinase 2 mutation. So I'm gonna just put these. So, and in all of these three, it's crucial, the Janus kinase. Although in polycythemia vera, in the really true one, 95% have the Janus kinase 2 mutation. In essential thrombocytosis, let's say 50%, and in myelofibrosis, less than 50% have this mutation. But it's very much connected with this mutation. And polycythemia vera is very special in a way that, watch out, this is the only out of these diseases, and basically out of all of the diseases, where you can see increase in all lineages of the, let's say, myeloid part. So you can have increased erythrocytes, you can have increased leukocytes, and you can have increased platelets. Not in CML. Over there, typically erythrocytes are like normal. You can have increased neutrophils or thrombocytes. Or in essential thrombocytosis, again, mainly you will see thrombocytes increase over there, okay? But in polycythemia vera, if someone asks you, yeah, over here you can have increase in all three lines, which is very typical, okay? So this is only true polycythemia because all of the lineages can be increased, okay? And the erythrocytes dominate, so erythrocytes are increased, and you can have thrombocytes increased, and you can have also leukocytes increased, okay? So that's why also in this case, there is a hyperviscosity syndrome. So that's a big risk. It's in all of them, but hyperviscosity syndrome in polycythemia is very typical. So there is an increased risk of thrombosis. And basically, what we see over here is a one special thrombosis. So there could be any kind of thrombosis, but also the Budd-Chiari syndrome. So remember Budd-Chiari syndrome, it's very typical in polycythemia vera, and this is a occlusion of hepatic veins, okay? So it's an occlusion, thrombosis of hepatic veins, which could be very lethal. Of course, if there is a blockage of the hepatic vein, the blood is not able to exit the liver, you can have ischemia and necrosis of the liver, and of course, because the portal vein is the one that brings the blood to the liver, and if there is no way how the liver can get rid of the blood, then you're going to have portal hypertension as well. Okay, so Budd-Chiari syndrome, very fast and very dangerous. Another thing you can see, and I will sort of divide it here that we're not mixing it together. What is typical is also flushed face. Is you have so many cells, and so typically they have a flushed face. They can have a blurred vision. This is connected with, let's say, the viscosity of the blood and ischemia of retina. That's very typical. Also, where you can have a blurred vision is in essential thrombocytosis. Okay, so I will put it here, blurred vision. And what is so typical with polycythemia is, remember, this is what they're complaining of, because they have lots of mast cells. Okay, lots of mast cells. And these have histamine. And typically, if you go to a shower and you shower yourself with warm water, typically, then there is a serious pruritus after that because the histamine gets out, they degranulate the mastocytes, and it's itching. So it's very itchy after shower. So after showering, they have a pruritus. So, and that's what they are complaining of. So it should ring the bell if someone comes as a higher erythrocytes and they complain of this. Watch out, there could be a blurred vision as well sometimes, like episodes of blurred vision. Yeah, it could be polycythemia vera, okay? And what's the problem over here? Or what could this be similar to? Well, this could be similar to, of course, reactive polycythemia, okay? Of course, in this case, the thing that would be really increased would be erythrocytes. But what is reactive polycythemia? Well, typically, like a differential diagnosis, typically if we have something with lungs, if there is a, I don't know, let's say COPD or restrictive disease, we're going to have decreased levels of oxygen in the lungs. This will trigger EPO increased from the kidneys, and we'll have reactive polycythemia. Here in Europe, it's better say polyglobulia. Okay. Another disease that we could have and could be bit or resemble polycythemia vera is unfortunately renal cell carcinoma. So renal cell carcinoma in some percentage produces EPO, high EPO. So again, there's going to be increased erythrocytes. But in both of these cases, if you take the blood, you will see high EPO. And that's the big difference compared to polycythemia vera, where there will be actually, so versus, there will be decreased EPO. Because what happens over here, the mutations already activates the receptor for EPO itself. So you don't need EPO at all, and this drives the cells to multiply, okay? So as a differential diagnosis to polycythemia vera, remember reactive polycythemia, or renal cell carcinoma, or Gravitz, it's called Gravitz also, Gravitz. That's old name for renal cell carcinoma. That sometimes produces also EPO, okay? So that was about polycythemia vera. Of course, again, and maybe I should, okay, I'm going to draw it over here. As I said before, as polycythemia or CML and polycythemia, yep, in 1/3 or in 2/3, this can unfortunately transform into AML, and in 1/3 also to ALL, lymphoblastic leukemia, okay, both of these. Also, watch out, and this is very similar to the next two diseases. In some cases, we could say 10 to 15%. What happens is that the cells will start to produce PDGF. Typically, megakaryocytes will increasingly produce PDGF. And so platelet-derived growth factor, if it's increased, and this is later in the disease, it can stimulate fibroblasts. So we can call it like post polycythemia vera, whatever, myelofibrosis, because PDGF mainly, but there are other factors, is very much responsible for change to myelofibrosis. Okay, so remember, polycythemia vera can either transform into acute myeloid leukemia or acute lymphoblastic leukemia, or it can transform or change into myelofibrosis in some percentages. Okay. And I will still talk about PDGF now because this is typical for essential thrombocytosis and myelofibrosis, actually. Okay. And in this case, when you have myelofibrosis, like secondary myelofibrosis in the polycythemia, you're going to have pancytopenia. So from the polycythemia of all the lines, suddenly you're going to have pancytopenia. Okay. Again, in some percentages. I will still try to divide it here, not to mix these diseases together. And now we're heading to essential thrombocytosis. And as I said, typically what dominates over here are thrombocytes. But because thrombocytes are, let's say, derivatives of a cytoplasm of the megakaryocyte, and the megakaryocytes are increased, but not as much. Typically, you don't see hyperuricemia over there. So that's typical. So there is no hyperuricemia as in polycythemia vera or in CML. So rather no hyperuricemia. That's typical. But on the other hand, the production could be in two ways. They're increased, okay? They're increased, the levels of the thrombocytes is increased, but either they could be functional or malfunctional, okay? It always depends how well they are produced. So basically, you can have two extremes, although you have increased thrombocytes. Either there could be a risk of thrombosis or risk of bleeding. Okay, so they're at risk of this or that, depends what quality the final thrombocytes have. But anyways, everything is about megakaryocytes. But in this case, the megakaryocytes, they look normal in a way. There's more of them, but they look pretty normal. And this is a big contrast to myelofibrosis. And I'm going to write it over here already, but still I'll make some space here for that. Okay, so in myelofibrosis, the megakaryocytes, they rather look abnormal. They look dysplastic in a way. Okay, so they look abnormal and dysplastic. And also, what happens over here, they produce a really, really huge amounts of PDGF. And I'll jump back. We're going to come to myelofibrosis, but in essential thrombocytosis, they produce higher levels of PDGF, but not as pathological. So in this case, I'm producing lots of thrombocytes. They're functional or not. But what is special about essential thrombocytosis? Well, first of all, they don't transform. So you won't see a transformation to AML, or it's really less likely. What you can see over here, and that's like in 10 or 15%, is a change, and it's a change from essential thrombocytosis to myelofibrosis. This is what you can see. So basically, this megakaryocyte, which looks pretty good at the beginning, can get more mutations and will produce more and more of the PDGF. Okay, there could be also a SLX. This is a mutation that at the end also changes the megakaryocytes into producing really high levels of PDGF, SXL1, which happens, and this sort of changes the megakaryocytes into dysfunctional megakaryocytes. And this at the end leads to, so they will produce, or this is a mutation that at the end also changes the megakaryocytes into producing really high levels of PDGF. And not only of that, but also, let's say, TGF beta, for example, but you don't have to know that. And this transforms it into myelofibrosis. So in a way, we could say secondary myelofibrosis with its pancytopenia. Okay. So the difference between essential thrombocytosis and myelofibrosis is the amount of PDGF, basically, and that the megakaryocytes, they look pretty normal in essential thrombocytosis, but they really look dysmorphic and pretty awful in classical myelofibrosis. Okay. And we're getting to myelofibrosis. So in case of myelofibrosis, over here, really, there's an increased level of PDGF. And this triggers fibroblasts to produce fibers and basically destroy or squeeze out the population of the hematopoietic stem cells from the bone marrow. So basically, the bone marrow starts to be occupied by the fibrotic tissue, and the stem cells have to move to other places. So basically, they move back towards the embryonic places. So they move to spleen and liver. Okay. So the production, still there is some basic production in the bone marrow, but the majority then travels to spleen. And unfortunately, you have lots of bone marrow normally, but over here, typically, the production is not as productive. So at the end, of course, you're having first at the beginning of that, under the PDGF, whatever, you have increased levels, but at the end, all three cell lines are decreased. Okay. So in all lines, basically, because everything is decreased. So you're having pancytopenia. So in case of, let's say, myelofibrosis, in the blood smear, what we see, and I'm going to write pancytopenia over here. So at the end, you have pancytopenia with its all consequences because you are impaired immunologically, so you have infections. You have bleedings because you don't have enough of thrombocytes, and you have anemia. Okay. But what else you see in the blood smear is, and there are two things. As I said, the production is moved to spleen. So what you typically see over there on the smear is so-called leukoerythroblastic smear. So leukoerythroblastic smear. And what this is all about, it's because normally in bone marrow you have fibers. You have reticulin fibers, which work as a filter. And the filter is able to release only really small cells. That means mature cells from the bone marrow. So the blasts are blocked in, they're bigger, so they're blocking the bone marrow, they're not able to escape. But as the production moves to spleen, we don't have any filter over there. So also the blasts, which could be pretty okay, are still released to the blood. So that's why you can find them on blood smear. So that's why we have a leukoerythroblastic smear. So there could be like, let's say, blasts in the direction of the white cells and in the direction of the erythrocytes. So there could be erythroblasts and there could be myeloblasts, okay, for example. So that's on one side. On the other side, as I said, there's a decreased production of cells within the bone marrow still. There's some basic production in the bone marrow. But because there is lots of this fibrotic tissue and there is a huge fibrosis, then the filters are getting even smaller. So typically when the erythrocytes wants to get out, it has to squeeze out through this smaller filter hole. And typically what you will see on the blood smear. So on one side you see erythroblasts and whatever. On the other side you see deformed erythrocytes, and they look like teardrops. And what do you call them? You call them teardrop cells. And this is high yield, and this is question in test. Okay, so remember, typically in myelofibrosis, there are teardrop cells in the blood smear. Okay, so it's a hallmark. There's a pancytopenia, and there are teardrop cells. And still, essential thrombocytosis, it will not transform. If I should say yes or no, very unlikely it would transform. But with the myelofibrosis, this again likes to transform. So I can still put it here. And again, in same ratio, it's able to transform into AML or ALL. Okay. So yeah, these are the four main entities of the myeloproliferative neoplasm. So it's chronic myeloid leukemia, polycythemia vera, essential thrombocytosis, and myelofibrosis. Okay. If you look at these, the one which is like most friendly would be the essential thrombocytosis. Okay. Okay, so that was about myeloproliferative neoplasm. Still. So, thanks for watching, and don't forget to subscribe and ring that bell. And as always, check the description below for supplementary questions and other materials.